So now let's focus on the chemical properties and chemical properties and the structure of chemical period 3 elements. And the reason why is that when we look at the structure of this, we can then predict the two properties we must learn or understand: their melting points and electrical conductivity. Okay, so that's important. So now what you must recognize is that these guys are that are in period 3 are happen to be what? So what are the species we have? So the species we have sodium, those are the first guy. We have sodium, then we have magnesium, then we have aluminum, then we have silicon, phosphorus, chlorine, argon. 11, 12, 13, 14, 15, 16. Oh, I missed out sulfur. I knew I missed out somebody. So this is what we have. Okay, now basically what is their structure? How do like these guys all have a structure? You must remember this, like their first three elements tend to be, these three tend to be metals, while the rest of them are non-metals, and therefore that affects their structure also. Okay, now when we say metals and non-metals, it affects multiple things. So let's say I have these guys, right? Because of that, it affects their bonding. So this is then the first thing we're going to look at is bonding and then structure. So when we talk about bonding, for metals the bonding is metallic, right? And for non-metals the bonding is covalent in their molecules. Now you might say, how? Well, what is the species in the bonding? Now if you think about species in metallic bonding, what's the species? It's cations in a sea of electrons. So sodium, magnesium, aluminum. And then when you have these guys, silicon is a macromolecule of atoms, phosphorus is found as P4, sulfur is found as S8, chlorine is found as Cl2, and argon is monoatomic. And so I tend to just, let me just align these fellows. And that's the bonding I'm talking about. Now because they have this structure, they have these species, they have a structure. So these three are giant metallic lattice. These three. Silicon is a giant covalent molecule. Giant covalent, it's a macromolecule, giant covalent molecule. And the rest of these guys are what we know as simple, they have what we call a simple molecular structure, or another word is simple covalent molecules. That's what these guys are. And the simple molecules, their properties are determined by their intermolecular forces. Silicon is just like a diamond, and these fellows are metallic lattice. If you don't know what these all look like, I can show you P4. P4 looks like this. There's one phosphorus here, one there, one there, one there, and each phosphorus bonds to all the other phosphorus by single bonds. So each actually makes 3 bonds, and this one is behind these two, like that. So that's P4. For some of you might have recognized S8. You do this, in your earlier years also, but that's SSS, and then atom S, atom S, atom S. And that's like an inverted crown or a crown. So these are two molecules, S8, P4, but they're still simple molecules. And so these fellows have a simple molecular structure. They're covalently bonded, which means you can figure out their boiling points and melting points, right? So if I had a row here for melting points, these fellows would be low, 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 simply. Okay, and silicon is high because that's a giant molecule that would look something like this, and you are expected to know how to draw it. That's silicon. And then you have bonds like this with Si. This can bond here, like here, like that, and it continues on, that kind of thing.
Quick pause. If you're finding value in this explanation, there's so much more to discover at Alt Academy, where we break down every A-level concept with the same clarity. Now back to the video lesson.
So it's a giant molecule, melting point is high. Now the giant metal species has one anomaly. Generally metals have high melting points, and it is true for magnesium and aluminum. But group 1 metals have low melting points, they melt easily. So this is low, high, very high, and then low, low, low. But you don't write very high, just write high in the exam. So you're expected to know this. So you're expected to know the species, the structure, and therefore the bonding, and then hence the melting point of all group period 3 elements. Okay, and you are expected to also sketch this out. So the kind of graph that we have for melting point is quite fascinating. I'll put it on the left right here. This is the graph. Okay, it might look not very large, but it is. I mean I'm not a large picture, but you can understand, you can see it. So sodium is low. Now this is in Kelvin. It's about 300 Kelvin, which is like just above room temperature. So sodium melts pretty easily. Magnesium and aluminum are very similar, we call them high. Silicon is even higher. And then you have these variations. This is for P4, this is for S8, and that's for Cl2, and that's for argon. And here amongst these four does your intermolecular forces explanation come into play. All of these four are simple covalent molecules. They are held by instantaneous dipoles, induced dipoles, attraction. And what do you know by instantaneous dipole, induced dipole attraction? That it depends on what? On electrons in a molecule. And that's important because when you look at P4, S8, Cl2 and argon, the number of electrons are 4 times 15, 8 times 16, 2 times 17 and 18. And the most electrons are for sulfur as a molecule, and that's why it has the strongest intermolecular forces amongst these four. Therefore, it has a higher melting point. Then comes phosphorus, so it's lower than sulfur, higher than the other two, because it has the second most number of electrons, so greater attraction than everybody else except for sulfur. And chlorine has 34, which is more than argon, so it's higher than argon. So this section is more like intermolecular forces from bonding. But knowing that silicon is high, it's a giant covalent molecule, is important, because sometimes people forget that. The thing is covalent, it must be low. Okay. And obviously here we've already discussed that the first three guys are metals, so they have a metallic lattice. This guy hello is a giant molecule where you have to break covalent bonds, that's why it's very high. And then when you have simple molecules, you don't break covalent bonds, you overcome intermolecular forces which are weaker. So that's why there are lower melting points. Now the only other thing that relates to the structure that you should know based on their bonding is their electrical conductivity. So sodium, magnesium have moderate conductivity, silver has very high conductivity, and then these guys are very low or non-existent conductivity. This is good or moderate conductivity. Mother is good enough, but it's not higher than this fellow. And why? Because aluminum has the most delocalized electrons. because it forms Al3 plus, and there are 3 electrons per molecule that get delocalized. Okay, so its properties it has a higher boiling point, higher conductivity than the other two, sodium and magnesium. So all these are metals, but because they increase, and the reason why the electrical conductivity increases is because the bonding electrons for a metal are as delocalized electrons, they increase. So the melting point increase and the electrical conductivity will increase. The rest of the molecules have low conductivity because they have no delocalized electrons. Now silicon is a semiconductor, so it doesn't really provide that much conduction, but it can be used and modified to provide lots of it. But on a naturally occurring form, it's we consider to have low conductivity. So the idea is, when we say silicon is a semiconductor, its conductivity generally is between a metal and a non-metal, a conductor and an insulator. But at room temperature, it is considered to be an insulator or having poor conductivities. Okay, you can therefore what we do is we either increase the conductivity of silicon by adding impurities or by increasing temperature. But as pure form at room temperature, it is a very low conductor of electricity, just like the non-metals are. Now these are some of the physical properties you're supposed to know of a group period 3 elements: their electrical conductivity and their melting points. Next up, we'll be talking about the reactions of period 3 and their compounds.
Hey there! If you found this A-level chemistry lesson helpful, why don't you head over to our website, altacademy.org, where you can sign up for the full A-level chemistry course. In addition to chemistry, you can sign up for physics, biology, math, or 4 other A-level subjects. Thousands of students have already taken the leap. What are you waiting for?